Hey folks, Segasonicfan here, and today I'm going to be repairing a subwoofer. This is not just any subwoofer though. This is a JBL Studio subwoofer, the LSR 2300 series. Whoops, knocked the tripod there. This is a very nice studio subwoofer that was given to me, which I'm very excited about because I've always wanted a very nice subwoofer such as this. And it blows out of the water your standard home theater 5.1 channel subwoofer. I mean, it blows it out of the water. Studio subwoofers are so nice. And JBL generally makes pretty good stuff. So what's wrong with this one? Well, a couple things. One is this frame is not supposed to come off. No, sir. There are 6 threaded inserts. I'm sorry, 8 threaded inserts that have all been broken off on the front cover of the speaker itself, which sucks because if this person wanted to see the speaker, all they really had to do is pop out this guy, which is designed to come out, but the frame is not. So I'm gonna have to go in and epoxy or do some. I use the Premium 3X construction adhesive, kind of a liquid nails deal, which works quite well for plastics. It doesn't have a dual process curing agent, which I like, but I also have the JBL epoxy stuff, which is pretty good too. So I'll be using one, or I don't know, I'll have to figure out which one of those I'm going to be using to fix that part of it. But the reason this was actually being given away was because it has a humming sound, and there was a video already on YouTube talking about that, which is to my fortune, so it saves me a little bit of troubleshooting. But I figured I'd also offer a little bit of detail here and sort of a little review as well. This subwoofer sounds really nice, like really nice, and there's a reason for that. It's got really thick-walled enclosure. I mean, it's really good construction, and it doesn't have a bunch of dampening everywhere. It's actually only got one side with dampening material, which is kind of interesting, and I guess they're actually using the enclosure to reflect the sound more. You can see right here the toroidal inductor transformer, which is usually better quality, although I have to look into why that is. I know those are popular with hi-fi applications. The speaker diaphragm, I mean, you can hear that just from my finger. It sounds really nice. I want to say it's a polypropylene type material. It certainly feels like that. And it's a gorgeous looking speaker. I might turn this around later to take a look at it, but you've seen speakers before. It's just a nice looking speaker. As you can see here, one of the dead giveaways that this is a studio monitor, of course, is the XLR availability here for balanced inputs and outputs, which is super sweet. And you have, of course, your 1/4 inch, and you have RCA. You know, I don't know if any of you out there are engineers designing audio equipment, but oh, mother, do I love it when you have XLR, TS, 1/4 inch, and RCA. The only thing missing, of course, is the 1/8 inch, the 3.5 millimeter headphone style jacket. When you get all 4 of those on a panel, you are my best friend, because boy, do I love that. However, this is going to do very nicely. Got your voltage select, got of course, your voltage input, and I'd like to point out, not only does it have a fuse holder right here, it even has the marking for the fuse right above that. That's pretty cool. 120V or 250V if you flip this switch, of course, for overseas. And you've got a crossover frequency, you've got a phase inversion for polarity, and lastly, you've got a very nice rotary knob, which I don't know if it's a... I'm sort of thinking it's actually in fact, I'm almost positive actually it's a analog potentiometer, but it's actually got indentation divots, which is really sweet. So you can hear the kind of subtle clicking, click, so you know where you're at. But it does stop in either direction, which leads me to believe it's an analog potentiometer. One of the coolest, in fact, I will say the coolest thing about this design is you have the heatsink for what I believe is probably a Class AB amplifier. It's not a Class D, which I really like. I don't like the sound of Class D, even though I know it's popular for subwoofer amplifications because of its you know, low power consumption, high energy efficiency. Class D amps, by the way, are characterized by their use of pulse width modulation, PWM, for amplification, for amplitude, and essentially they sound kind of digital because in a way they are kind of working in a more digital fashion. Maybe I'll go into that in another video. But what's so cool is it's using a old school Class A B, and then it's actually using the vented enclosure as a way to dissipate heat, which I think is super smart. And so you've got the heatsink fans going into the vent there. Very cool. Got a bunch of nice high quality capacitors here, which is always nice to see in audio gear. A couple of SOIC 8s for your preamp stage. Nice big chunky bridge rectifier, nice big chunky capacitors. Also, you know, kind of the three things that are a really good sign of old school analog design. You have your toroidal power transformer, your bolt capacitors, and your inductor. If those parts look nice, those are expensive. Like, you can't actually cut too much cost on those. They're just large, expensive parts, always have been. And those look really great. I also really like how they've actually enclosed all the panel components in their own plastic enclosure. Really, really nice design, because air leakage is a huge problem with the panel components in any subwoofer that has, or any speaker system that has a bandpass filter like this. I'm sorry, not a bandpass, a vented enclosure filter like this, because you want the sound to come out this vent, right? You don't want it to leak out various components. It creates rattle a lot of the times. It's not actually so much for a sound, it's not so much that it affects your sound output as much as it adds to it unpleasant sounds that you don't want. What else can be said? It looks like somebody took off the ground on this. That's kind of concerning. I'll have to find a missing nut for that. I'm not sure why someone made that decision, but there it is. There's two plugs. You got a 5-pin and a 4-pin kind of Molex style, though I feel like they're probably JST, whatever the step is above XH, I forget. The 5-pin one with the yellow and blue wires goes here, and the 4-pin one goes here with the black and red. One is for, are they both for the power supply? Yeah, because one's for the AC input, the rectified AC, or not rectified, pre-rectified AC input. Am I getting that right? Ah, one's for the power switch. No, actually, I'm not sure. Yeah, no, one's for the wall, the line voltage, and one's for the, they're both, neither one of them are rectified, they're both AC, right? Because one of them's going to the mains, going to the inductor coil, and then the other, the transformer inductor coil, then the other comes out here. It gets rectified, of course, by the bridge rectifier. So where's the problem? Well, and one last thing I'll point out, you have a nice little fuse here, which is pretty cool. A little extra glass fuse for the power rail on the power amp stage. They did not need to add that. That screams quality, and I really like that. Let's go ahead and maybe give it a little more light here. I'm not getting the best picture quality for some reason. Maybe I'll change the exposure and see what happens. Yeah, that seems to help. So, yeah, here we are with the motherboard. Here's another close-up shot. You can get a glance at everything. And you can see this is the connector here going to all the panel I/O stuff, which is under this large piece of black plastic. Very cool. And I'm actually guessing this might also be a fuse for, so they have a fuse for each power rail. There's the other fuse right there, of course. And the amps, which can't really see super well, and I was using my magnifying headset. Where did that go? Let's look at these just a second ago. But maybe I can catch it on camera here. They're TDA amps, which is, I guess, ST now. Philips used to use the TDA, if I remember correctly. But Philips and ST might have merged. There's been a lot of chip manufacturing mergers lately. Of course, this is not lately. This is from 2008, but this is a TDA 7293. TDA 7293. And I apologize, but it's not being caught on camera very well. And such is life sometimes. But this capacitor brand is not the greatest. Chang, there's no Nichicons to be found in here. And so you have one design flaw, which I believe is what leads to the humming, from what I understood from the other video I watched, and I'm going to replace it and find out. And it's these two bolt capacitors. They're 470 microfarads at 35 volts, you can see there. Also, oh, by the way, for other I/O, I meant to point out, quick tangent, this is your LED output plug, and then this is your one of your speaker connections, and the other one is over here, the black red right there. So these capacitors, I believe, go bad. They dry out. Why do they dry out? Well, same reason they always dry out. Heat. Heat is not the friend of electrolytic capacitors. Why would there be heat? Well, designers put these two guys right here. And you notice they had heat sinks originally. They probably removed them to save cost. So maybe you can't even blame the designers. You can blame the people that are doing the bill of materials stuff. They're trying to save their pennies, because these are 7-8 regulators, or 7-915 here and a 7-815 for the negative. That's a negative 15 volt regulator, and that's a positive 15 volt regulator. Very likely for the op amp stage, because op amps like high voltage swing between the positive and negative rails to create a nice analog curve. And so it's good that they have these in here. They're nice big voltage swings, but you know, they're generating heat from whatever the positive supply voltage is coming to these guys, which if we look here, it says 63 volts. So I wouldn't be surprised if there's 40, 50 volts plus. I guess it wouldn't be that high. I don't know if these guys can take quite that much voltage, but in any case, they're taking a substantial amount of voltage and power and converting that down to 15 volts. And so that generates heat. Even more than that, you have these two high wattage resistors, which also indicate to me, and in fact, you can almost see a little bit of browning there, that those get hot as well. And so these two large capacitors being in close proximity to these heat elements would no doubt lead to them drying out, because electrolytic capacitors have a liquid inside of them. And they're cheap and crappy to begin with. So thus is the nature of electrolytics, but they're the most affordable for the capacitance values which they represent, which is why they're used in everything. So all this stands up to reason and to my analysis of what could cause a failure. And so in this case, it seems very likely to me that that's going to be causing the humming. And so I'm going to go ahead and replace those capacitors. I'm going to do a test after that. Of course, I'm going to fix this missing ground wire connection right here. That's very important. And then I'm going to have to epoxy repair this cover. As mentioned previously, the 8 points of contact that have threaded inserts, neural shaft threaded into neural threaded inserts into the plastic, which fortunately are still available on the front. And that should get me going here. A little bit more work than I was expecting, but I think it'll be worth it in the end to have a very, very nice studio subwoofer for free. I'll go ahead and turn this around so you can get a look at the speaker cone, and you can see here also the parts that broke off. I don't know. Someone must have been having a real bad day when they were just, I mean, like, what do they use, like a crowbar or something? How do they even do that? I don't know. But it's a nice speaker, and yeah, even just tapping on it, you really get a feel for how nice it sounds in that enclosure. So, and you know, just the quality of it. It's real nice. Holding up really well too. This system is supposedly from 2008, so I'm sure it's seen some wear and tear, but I think the rubber on here is feeling really solid. Doesn't look like it's going to be giving out anytime soon. So let's go ahead and get this repaired. Play some music, drive my neighbors crazy. What else is new? This is Segasonicfan, following up after this. All right, folks, and I'm back with the JBL 2300 subwoofer speaker repair. That's not the exact model number, there's a couple digits, but it's the 2300 series. And you'll see here I did a couple of my own modifications here to kind of make it so I don't have to do this repair every 5 or 10 years. I did replace those two capacitors, but in addition, I also desoldered the two resistors, and it's hard to tell here, but I kind of angled them a little bit away. Even just 3 or 4 millimeters can make a difference because you're not pressing them against those capacitors with all that heat. Additionally, I added a heat sink with this kind of heatsink foam stuff. Only one of these is secured with a screw, so I didn't feel like drilling into the aluminum. I could do that with my drill press in the other room, but I just don't think it's necessary. This is on there pretty well. And then I also used what I never get to use, because I've had this since I last did a speaker project like this, which has been a while. This stuff, which is incredibly overpriced, and is a high-performance adhesive used for, it's the kind of black gunk that you see here holding all these speakers in place, or sorry, capacitors in place, from the vibration, of course. Because the sound vibration and the sound pressure in here can be quite a lot. I think it's like 160, 180 watt speaker subwoofer. So, but I want to let you all know a couple things. One is if you want to save some money on that, but have that same kind of feature, you can usually get away with caulking sealant. You can use black caulking sealant, which is about $10 or less. And that's worked quite well for me in the past. A couple other things to note when you're working on this: try not to put pressure on the knob here, this analog knob and this volume in the back, because you don't want to damage that. Last person who worked on this put a lot of pressure on this, and I think it's still working, but I'm going to have to spray some deoxit just to get the sweep to not have any noise. Also, when you first remove all the screws, including the two for the amps, there are some kind of teeth nuts there, sorry, washers under there. Those kind of like sharp teeth washers that kind of clamp on better. So keep in mind those might fall out. Just, put them aside. Also, when you undo all the screws, you might notice it's not going to come up actually right away. And the reason is in addition to having a plug right here for the I/O board, the outputs and the inputs on the back, there's actually a foam adhesive around that plug, again, to seal off any air pressure. That foam piece, of course, rips as soon as you lift it up, but I think it's still enough of a seal, enough of a decent gasket. If it causes any problems, I'll deal with it later, but I think that's pretty darn minor because the foam is still there. It's just broken in a couple joints. Yeah, I think that's it. I put a little bit of that stuff here, the adhesive, the flexible adhesive stuff around the heatsink, so it doesn't wobble too much from the air pressure as well. Not sure that's going to do too much, but we'll see. So I'm just going to fire this up and see if everything works well, and if that's the case, I'll start doing the epoxy for the cover and then call this a day. Okay, back with more JBL 2300 series repair stuff, and I'm feeling pretty confident about the motherboard, but I'm not going to test it until I get the cover worked out, because reaching the screws for the front panel here, I have to put my arm through the back, and it's going to be really hard to do that with the short cables that connect the motherboard. So as you can see here, I applied some premium 3X liquid nails construction adhesive. It's this stuff, which always seems to harden no matter what I do, and I have to drill, literally take a rotary tool and drill into there to get and try to squeeze out what remains. It's great stuff, but man, it does not keep over time. Anyway, I put a bunch of it, as you can see, on the standoffs, the threaded inserts here in the standoffs. I mean, someone did a real job here breaking every single one of those, and I'm a little worried about how it's all going to hold up, because of the weight. This plastic and the metal grill are quite heavy. I actually want to say they're probably close to about 7 or 8 pounds, which is really unusual for, a plastic cover on something. So in addition to the weight, there's just not a lot of structural support. And as you can see, I've tried to add structural support by putting extra glue around those standoffs. But I'm quite concerned. And what I'm mostly concerned about is, well, there's two things I'm concerned about. So one is, you'll see there's a gap around this screw, and I've measured it with my calipers to 6mm gap, and the screw width measures about 3.7, 3.8 millimeters. And so what happens is this gap, as it is now, is actually working as an air vent, which is not good. Can create rattle with the screw and, of course, mess with your sound, because you want all the air to come out that one vent in the back. You don't want any air leakage. And they've gone to great lengths to prevent air leakage in the I/O interface in the back, but really didn't do it up here very much. I mean, aside from the sealant they put around this connector, which also could probably use some more. I do have some black caulking solution I might use for that. We'll see. In the meantime, though, what I thought would be great, kind of two birds with one scone, as my friend says, feed two birds with one scone. I like that phrase. Is what I want to do is create two things. One is I want to seal up that gap. And the second is I don't want the threading on these inserts once they get tighter to basically break the insert loose from the already broken plastic standoff. And that's really likely to happen once the insert meets flush with the material here, because there's nothing to prevent it. You know, it's just going to be pulling on, you know, the more you thread it, right? The more it presses against that. And so if I could create a way to reduce that pressure against this panel and fill in that gap at the same time, that'd be pretty cool. And so that's what I'm doing, actually, and I'll show that in a second. I'm 3D modeling, and I'm going to 3D print with some TPU filament, some flexible filament, a spacer that both fills this gap, goes around the screw, and then has a washer, essentially a flexible washer on the top, which I think will do the trick. I'm actually pretty optimistic about this, assuming the measurements work out right. Getting dimensional accuracy with a 3D printer is not the easiest thing, and I'm still working on getting good at that. But I think if I even can get close, fairly close to the dimensions within a 0.1, 0.2, and if I print it at a 0.16, you know what I'm saying, 0.16 millimeter resolution, then I think it'll work out pretty well. So I'll show the 3D model, and then I'll print this, and we'll see how it goes. All right, so here I am with the 3D model that I've made of this very simple kind of washer spacer combo here. And just using Tinkercad, because I'm still a noob with some of this stuff. I'll go ahead and deunify. I don't know what the correct phrase is for that. And you'll see it's really quite simple. I've just done a 3.75 cutout, since it's around 3.7 and 3.8. I feel that way the screw threads, might kind of push against this a little bit, which is okay. It's flexible filament. It should be able to take it. I wanted to make that gap pretty narrow because I want it to actually seal air, ideally. It's a little bit overkill. I might scale it up if I need to. We'll see. And then, yeah, just made a 2 millimeter height washer, essentially, which of course I could trim to 1 millimeter if I need to. And then, yeah, I've got this guy at 5.9 since I measured 6 for the opening, and I'm expecting tolerance issues since my printer is not dialed in for dimensional accuracy yet. So I've unified all that, opened up my slicer, which in this case is a Creality rebranded version of Cura, and I accidentally don't have the G code, or I don't have the resolution set to what I want. Actually, let's do it. I have it to 0.2. But let's go ahead and set it to 0.16. What I've also done, I guess I could share with you my slicer settings for TPU, even though it's, you know, like I said, I'm pretty new to this. Nothing. Don't take my word for everything, basically. Infill pattern set at 20% because I want it to be not super flexible. I want it to have a little fair amount of rigidity, actually, for flexible filament. Print speed for really small parts like this, I always go down to a really low print speed. I'm doing 10 millimeters per second. And of course, I need to change my travel speed here. That's way too high. Change it to like 30. And this will increase the print time by 5 minutes or something. You know, it's really, really undervalued, I think, the value of slow printing. Retraction speed, I set this to 1.6 previously, and I got a little bit of stringies, so I'm setting it to 1.8, though I imagine 2 is probably the way to go. Retraction speed's fine, and some of these measurements I've gotten from, it's a combination of the recommended TPU settings from the slicer, the recommended TPU settings that come with the printer, and the recommended TPU settings that come with the filament, which in my case is Hatchbox TPU. So you have 3 different settings to work out, and this is what I have found to be working okay-ish at the moment, but we will find out. Go ahead and slice this and see what kind of processing time we're looking at. And we're looking at 13 minutes. Really not bad. I'll go ahead and preview this so we can see what's going to happen. I'm just going to do a standard skirt around it, and yeah, nothing special there. It's a really simple design, really simple geometric shapes that are hard to screw up. So let's get it printing and hope for the best. All right, here I am with the plastic standoff washer thing 3D printed here. on my Ender 3S1 Pro, and it's not coming off super easy, which is fine. Just you'll see this is the stringy from the retraction setting. So even at 1.8, I'm getting some stringies, which means it's fine. Just have to mess around with that in the slicer a little bit, and yeah, this isn't coming off on camera. I'm gonna have to use both hands, so I'll get off camera here and give this a shot, and we'll see what happens. All right, here we are with my upgraded spacer washer thingy, and I must say I'm actually pleasantly surprised. Even though the measurements weren't as exact as I was hoping, it's a little bit smaller than 6 millimeters. It really gets in there nicely, and because it's actually a little bit smaller of a print than the actual measurements, what I do is I actually thread the screw into the TPU, which seems to work out quite well, actually. And you'll see there's the textured bit from the textured PEI, but that doesn't matter. It is compressible, which is what's really important. That 2 millimeters seems to have been a pretty good choice for that. And really the only negative downside I can see from this is, and this is kind of important, this is kind of making me second guess myself a bit, but is the fact that let me turn on the light, you can see the standoffs here with the threaded inserts are flush with the kind of bezel of the rest of the frame here. And so by adding a spacer, there will be a small gap here. Now, that's only an issue if, well, I don't know. I can see that being a bit of a mechanical stressor if there's a way to push, kind of to angle things in the gap. But I think that's not going to be too big of an issue because there's 8 of these standoffs. And so if 8 of these standoffs are pressing against a compressed flexible washer, like the one I'm printing, then I think the angling isn't going to be too much of an issue. Like, I don't think this, I don't know. I guess I'm a little torn on it though. What I might do is print some strips of TPU for this guy, but I don't want this to be too involved of a project. I've already put a lot of time into this, or a fair amount of time into this. And I want this to be durable, of course, but I don't want to overdo it. However, I think if I did maybe just one on the, maybe 4 pieces, like 4 little strips, that might work pretty well. I'll have to use an adhesive, though, to get them attached to the bezel here. And, yeah, I guess I'm trying to think of the trade-off of what kind of angling issues there could be versus like, but then you have stuff like this, right, where I've actually gotten a little bit of the adhesive over the top of the threads. Let's see if I can zoom in on that. Sorry for the shaky camera. You see there's a tiny bit of material here extending beyond the nulled insert, and that nulled insert is what's actually flat. Refocus again here. That's what's flush with this, you know, the Z height here has to be the same, right? Or it doesn't really work. So I could sand that down, but of course that's something else that would be fixed just by itself by using my flexible TPU washer that I just 3D printed. So yeah, I don't know, give it a shot. I mean, I would have to also thread these individually and then thread those afterwards, which is also a little annoying. But I gotta say, the one thing it does do very, very well is it seals that air gap. And that's kind of what I care about most. In fact, that's what I care about more than this cover at all. So that's kind of an interesting thought too. If I just put a nut on the end of this, compressing this down, problem solved with that. Like, and even could have this as an exposed speaker. Not ideal, but it is another workaround, especially given that this thing is so heavy. And of course it's meant to be like kicked or whatever, you know, by musicians getting into the groove. But yeah, I don't know, kind of torn about it. Maybe I'll print a few more of these. I think I'll give it a shot. Yeah, I think I'll give it a shot because it does solve the air gap problem. I'm thinking out loud here, folks. More to come on this JBL 2300 series subwoofer repair. Okay, and here we are with all the little spacers printed out in TPU on my Ender 3S1 Pro, and they look pretty nice. All things considered, not bad at all. Have to refocus a lot to get my camera to pick up these, something this small. Come on, there it goes. And see if the light helps if I turn that on. Yeah, a little bit. So yeah, as you can see, retraction looks pretty good. I actually changed it to 2, was it millimeters? And we've got pretty good results here. So I'm going to go ahead and pry these all off and thread them in the screws, and we'll see how it goes. All right, so I'm back here with the TPU printed flexible washer and spacer all in one. And as you can see, these printed off really nice on the Ender S1 Pro. A lot of people have been saying they really like that Sprite extruder that it comes with, and I am one of them. Sprite extruder is just the marketing name for it. It's just a nice new extruder, all metal hot end with a dual gear drive system, direct drive system that works really quite well with TPU apparently. These were cinched to print. 0.16 resolution, and yeah, they turned out pretty great. So the fit is really nice and snug. It's a little bit less than 6 millimeters on the diameter of the inner spacer, the outer diameter, because I just haven't honed in the dimensional accuracy as perfect as I'd like it. The inner diameter is also a little bit less, but that works to my favor because that means I can actually thread it on the screw. And so with the combination of threading it on the screw, that being a really snug fit, and then of course the washer being pressed down being a really snug fit, that gives me an airtight seal there. And so all these are going to have an airtight seal, and that's going to be pretty great. And in fact, if I want to, I could just put a nut there and call it a day if I don't really care about covering that speaker up, and that would give me a nice airtight enclosure solution. However, I do want to have this cover on it, and as you can see, one of the things I've had to consider, let me refocus the camera here, is that the threaded inserts here are flush in Z height with the bezel of the frame here. And so because that's a flush connection, what that means is this spacer, this 2 millimeter height difference, is actually going to have it not be flush against the whole thing. And so I'm a little worried about some angling that can happen, which would eventually break these inserts again if something gets knocked. And, you know, these inserts are really on their last legs as it is already. I've added a bunch of extra glue, as you can see, construction adhesive to try to give them more support. But they're missing plastic. I mean, this thing just came to me in really bad shape. But what I'm going to do is actually print 2 millimeter TPU spacers for the corners as well as for the sides. I'm going to use a very thin adhesive because I don't want to add more space, right? But that'll actually give me matching spacers for all the sides and the corners in addition to these threaded inserts. And I think that's going to do me really well. There'll be a little bit of a gap, 2 millimeter gap around the edge for some parts, but that doesn't matter because this enclosure will now be sealed thanks to these nice spacers and, of course, the securement of the speaker seals, that opening there. I think it's going to be pretty cool. Whether it's going to hold up to somebody like kicking it or something, probably not. I don't know, but I think it'll be pretty good. I might actually also add some extra caulking sealant to secure this a little better. Talk about your short cables, though. I wish this one was a little bit longer. Maybe I'll make an extension cord. All right, so here I am with the JBL 2300 Repair all completed, and I gotta say I'm really pleased with how things turned out. With the lights on here, you can actually make out the TPU washers that I 3D printed, and these kind of bezel gap fillers. And the reason for that was because I added a 2 millimeter TPU washer and to the 8 screws here that of course pushes the Z height 2 millimeters all around the edge here. And so I went ahead and printed off these edge pieces as well to give more of a snug fit and fill in some of the gaps as well and make it so you can't necessarily pull up a corner as easily. I think it's actually really sturdy. I did a really careful job getting those standoffs reapplied with the premium 3X construction adhesive, and the threaded inserts in there all lined up really well, except for this one. The one in the middle was a little bit off. One other situation that I had come up was I actually had to replace one of the screws when this had been broken. Somebody actually bent the screw. That is really hard to do, folks. So someone really took their anger out on this sub, or kicked it or dropped it or something. But it needed a lot of care and kind of structural support because this plastic is really heavy. Got the blue LED there. It's all working. I mean, this speaker comes a little bit dusty, whatever. But I'm going to show it to you in action. I also used some caulking sealant for the gap where it's a JST-XH2 connector that connects to the LED there. That's all been filled. And we have a really nice seal now because of those TPU printed inserts. Those little insert washer deals that I printed 8 of. And so now let's go ahead and crank this up with a song that has a lot of low frequency. Oh, that's an ad. I'm gonna have to go back. Let's see. But yeah, I went ahead and I didn't actually print any TPU for the connector behind the I/O boards. That is another option I had thought about, to kind of recreate that gasket, and I would do that if I needed to. But on full power, this thing actually hurts my ears and does not seem to need it. So I'm turning it up. I don't know if with the compression, the online compression and everything, if you'll hear a lot of this. It's a very low frequency, but it's loud. I mean, everything in my room is shaking. And what's cool is nothing here is shaking. It did until I put in the last few screws for this back cover, because it really produces a lot of power, a lot of air pressure out this vent. But it's working fantastically, and gosh, I really couldn't hope for better. The pot is totally fine. Replacing those 2 capacitors, those 470 microfarad 35 volt capacitors, absolutely did the trick. I've now got the heat sink on the 2 voltage regulators, moved the high wattage resistors, they're like half a watt or a watt resistors, a little further back. And I think this one's totally done. I think it's good to go. If I want to, I could paint this corner, if I really wanted to get detailed, I could try to get rid of some of these scratches. But everything else is totally functional, and literally the only thing you'd be able to tell that this was damaged, in a real way, is just this one little gap here, which does not actually connect to any of the electronics. In fact, the speaker, all of it's totally sealed. This gap leads to nothing except the little board that plugs in the LED, and it's very hard to see if you turn off the light, or if it's under a desk where it's going to live anyway. So yeah, this is a really nice studio monitor. Studio subwoofer monitor, I should say, and I'm very happy to have repaired it. So yeah, hopefully this video is useful to you in some way. Happy audio engineering, audio repairing, and take care of your equipment, and it'll take care of your music for you. This is Segasonicfan, signing out.